All right, you guys, we've got video number 2 here, but actually the first of the practice problems. So we can't even get started right away because in the lesson that I gave, I never discussed the problems that involve metric units. The little bit that I did, I wasn't feeling the greatest yesterday and apparently wasn't thinking the straightest and may have given a few of you some misinformation. So I would like to take a second to actually go back and go back into these notes here. And what I want everyone to do is add one equation into this set here. So the thing we need to talk about is the x position doesn't matter. In the x direction, gravity does not affect the horizontal distance traveled. But gravity does affect the vertical distance because gravity is a vertical force. That little negative 16, okay, negative 16 is specific to US customary units, feet, inches, things like that. So when we go to use a metric problem or solve a metric problem that gives you like an initial height of so many meters and things like that, and a velocity of so many meters per second, we can't use this equation because our units will clash. We're going to have meters per second velocities and feet per second squared accelerations of gravity. It's a whole thing. So I'm here to set that straight, and I just want you to do this real quick. We're going to set this for metric. Metric is going to say y of t h naught plus v naught t. Okay, so as you can see, nothing has changed. H naught plus v naught sine t. Where did that parenthesis go? There it went. It's right here where we say negative 16t squared. For metric, we're going to change that. We're going to say negative or minus 4.9 t squared. Okay, so again, just add that to your notes, and then we're going to move on and do some practice problems. Anytime you have metric units in your setup, in your given information, make sure you use that for the y. Again, the x will not change. Okay, moving on. Looking at the problem, you throw a football horizontally off the top of the school. Okay, not sure how you got on the top of the school, but whatever. We're gonna pretend like you were given permission to do that. Anyways, I'm also not sure what school this is, but 30 meters. Let me see, rounding that. I mean, you're somewhere over 100 feet tall. Our school is nowhere close to that. It's like, what, 2 stories, 3 stories? It's less than 50 feet tall. Anyways, so you're on this really tall school that you have permission to throw a football off of, and you're going to do it at 12 meters per second, which actually is a pretty valid speed. The 2 questions, pretty standard. How long does it take for it to hit the ground, and how far from the base of the school does it hit? Okay, so let's set this problem up. Number 1. Question 1 will go blue. Okay, so question 1. Again, let's start every single problem the same way. Let's let's set up every variable that we know. So, do we know our initial height? Yes, we do. That is 30 meters. Do we know our, let's see, let's just keep reading. Initial velocity, 12 meters per second, so v naught. Okay, 30 meters high. Now, it does not, again, like the example we did with Wile E. Coyote, it doesn't say, and he launches it at this angle, but what it does say is that you throw the football horizontally. When it says horizontally, it means that you are launching it at straight horizontal in terms of angles, that is 0 degrees. So I do write that down, and I say that the launch angle is 0 degrees. Okay, all right, so we have what we need. Now we just need to plug and chug. So let's go to number 1, thinner, number 2, different color. X of t, that initial equation is v naught times sine alpha t. So what we have in this case is 12. Oh, I screwed that up, you guys. Sorry. Pretend like that has always said cosine of alpha, because cosine of alpha at alpha being 0 is cosine of 0 is 1, so 12 times 1 times t. All right, then we move over another color. What haven't we used? Whatever color that is. All right. Y of t. So the y position based on time is h naught, v naught. This one is sine of alpha. And we are in metric, so I'm going to use that coefficient we just talked about, negative 4.9 t squared. So what we get here is y of t is equal to initial height. Sine of 0 is 0. So initial velocity times 0 times anything times 0. It's just 0. So we really have the initial height minus 4.9 t squared. And okay, so we have our equations. We've plugged in the variables we know, and what we're left with is we know that at any given time, after 1 second, let's say, horizontally, this football has traveled 12 meters because the speed is 12 meters per second. Horizontally, it says that after 1 second, I'm 12 meters. After 2 seconds, I'm 24 meters. So in the x direction, that's pretty straightforward. But again, in this one, the height of the football. See, at time 0 seconds, t is 0, I just get that we started at 30 meters off the ground. After 1 second, I'm going to take and say that 1 second of gravity has dropped me from 30 to about 25. All right, so then after 2 seconds, I've dropped even further. But anyways, what we're trying to do is say, hey, when did I hit the ground? If you remember, we are really asking what time does the height equal 0? Because that's when you hit the ground. So 0 equals 30 minus 4.9 t squared. And then we have, instead of 2 unknowns, the y of t and t, we have 1 equation, 1 unknown. I'm going to add 4.9 t squared to both sides. I'm going to divide by 4.9. And I have no idea what that is, so let me get as close of an estimate. About 6.12. And we get t itself, take the square root of that, about 2.47. Okay, so we have answered one of the questions, the question of how long does it take for it to hit the ground? So 2.47 seconds. And again, I apologize, there's really not a lot of room on this to be working with. So you may need to just like have a separate sheet of paper that you're working with. I did not think that through, I guess. So again, my apologies. There's not really a whole lot of room to work with, which is why I'm working on my own separate sheet. But what it is asking you to do here, it's just asking for you to write the equation. So if you're wondering what the heck this is just asking for these two equations here and here. Yeah. So if we go back, it's really asking you to just say 12t here and 30 minus squared. The instructions were not very clear on why those equations are there, but it's the idea that you can do that and then later come back and answer much more questions than just when does it hit the ground and how far away. So going back real quick, we know that it took 2.5-ish seconds to hit the ground. Well, every second that goes by vertically, the same amount of time and distance is traveling horizontally. So after 1 second, we're 12 feet, 2 seconds, we're 24. So we get down far enough, we can see that x of t could be x of 2.47, which is 12 times 2.47. Which equals a distance of 29.68. And again, be careful, that is meters, not feet, not miles, nothing else. It is 29. We have to put it over here. So in a way, I'm putting it underneath. So how long does it take? 2.5 seconds. And how far from the base? I put the answer there, 29.68 meters. So there you go. Example number 1. No, sorry, practice problem number 1. Straightforward. It's a horizontal off the top of a school that you have permission to throw a football from, which is over 100 feet in the air, which is a very tall school. With that said, I will get onto another example where we actually launch something at an angle, because these, frankly, are getting a little bit tedious to not have an angle. But I'll do a couple more examples, and hopefully that'll help you out. We'll see you in the next video.